Today we'll take a look at some volume formulas as well as literal equations. Here are some formulas you should be familiar with. The first shape seen is a cylinder, and volume of the cylinder is pi r squared h, where r represents the radius of the cylinder and h is the height. Here's another shape, a cone. The volume of a cone is 1/3 pi r squared h. Notice the similarities between the two formulas. And here's one more shape, a pyramid. And the volume of a pyramid is 1/3 capital B, which is going to represent area of your base, times h, the height. Here's some practice with each of those shapes. The first example involves a cylinder. The question states that a cylinder has a height of 10 inches and a radius of 4 inches. Find the volume of the cylinder, and we're going to round our answer to the nearest tenth. Here's a picture for visual purposes. So once again, the height of the cylinder is 10 inches and the radius is 4 inches. When solving volume formulas, my first step is I always write down the equation. So since it's a cylinder, volume of a cylinder is pi r squared h. So once again, step one is to write the formula. Step two, after writing the formula, you're going to fill in the pieces that you know. For today's lesson, I'll be using 3.14 for pi. According to this example, the radius is going to be 4 inches and the height is 10. So once again, step one, write the formula. Step two, fill in the pieces of the formula. Now that it's time to solve, I'm going to follow my order of operations. So don't forget PEMDAS. Parentheses, exponents, multiply and divide, add and subtract. So looking at this formula, the first step is I'm going to follow the exponents. So 4 squared, 4 times 4 is going to give me 16. After figuring out the exponent part of my equation, I'm then going to multiply. So using my calculator for this part, 3.14 times 16 times 10 is going to give me 502.4. And because this is a volume question where the height was measured in inches and the radius was measured in inches, my final answer is going to be inches cubed or cubic inches. So you'll notice as I continue with the next couple of examples, I always follow the same process. Write the formula, fill in the pieces of the formula, and then follow my order of operations from there. So here's another example. This one asks us to find the volume of a cone with a diameter of 8 feet and a height of 9 feet. And once again, we'll round to the nearest tenth. So here's our cone. The diameter, 8 feet, the height is 9 feet. No matter what, the question says volume. My very first step is to write down the volume formula. So going back to several previous slides, the volume of a cone is 1/3 pi r squared h. After writing my formula, I'm going to fill in pieces of my formula. So for pi, once again, I'll be using 3.14. Now here's kind of a twist on this problem. It does state that the diameter is 8 feet, but my formula says that I need the r, which is the radius. So please remember that the radius is going to be half the diameter. So if the diameter is 8 feet, for r, I'm going to plug in 4. And then the height was given to me 9 feet. My next step, once again, let's follow those order of operations when solving. So exponents first, 3.14, 4 squared is 16, and then that leaves me with 9 at the end. And now I follow my order of operations. Don't let the fraction scare you. If you have a good calculator, you could probably type it in, but if you're using something more basic, a fraction is just a two-step process. The number on top represents what you multiply by, and the number on the bottom is what you'll divide by. So breaking this down, I'm going to do 1, since that's on top, times all my other pieces, so 3.14 times 16 times 9. And then at the end, I'll divide all that by 3. And that's how you can approach fractions when having a non-scientific calculator. So typing this all in, 1 times 3.14 times 16 times 9 would give me 452.16. Divide all that by 3. And I would end up with, to the nearest tenth, 150.72. Again, the units are very important when answering questions. Feet was my diameter, feet was my height, so my volume is going to be feet cubed. So we did an example of a cylinder and an example of a cone. Same process no matter what. Write the formula, fill in the pieces, and then follow the order of operations. Here's one more example. This time we'll be focusing on a pyramid. So the question states that the volume of the square pyramid is 378 cubic centimeters. The height of the pyramid is 14. Find the length of the base. So this question is a little different. Rather than finding the volume, it was given and we'll be solving for a different piece. Here's a picture for visual purposes. So here's my pyramid, and it's a square pyramid since the base is a square. No matter what I'm doing when working with volume, I'm always going to write the formulas. So volume of a pyramid from the previous problem is 1/3, or previous slide I should say, big B, which is going to represent area of the base, and then H for height. This time when I fill in my pieces, I know the volume, and it's 378, so 378 equals 1/3. The area of the base, I don't know because I'm solving for part of the base, but the height is given to me as 14 centimeters. There's a couple ways to approach this problem. You could, on the right side, multiply 1/3 by 14, but to be honest, I can't stand fractions and I find them frightening. So anytime I see a fraction, my first step is always to get rid of it. So how am I going to get rid of the 1/3? I'm going to multiply both sides by the reciprocal, which would be 3/1 or just 3. So making it a little easier for myself, multiplying everything or both sides by 3 before I get to any solving. And I'm just doing this because I cannot stand the fractions. So on the left side, 3 times 378 would give me 1134. On the right side, 3 times 1/3 gives you 1. It disappears, which is why I did all this. And then big B, 14. Now to solve for big B, capital B, which stands for area of the base, I'm going to divide both sides by 14. Always use those inverse operations to isolate your variable. And 1134 divided by 14 is going to give you 81 equals B. Now most students would stop here, and this is actually a trick. Remember, the capital B stands for area of the base. And this question wasn't asking me to find the area of the base, but instead it was saying to find the length of the base. So let's use another formula. The base of this pyramid is a square, and the area of a square is S squared, or you could simply use length times width. Well, I know that the area of this square is 81. And what do you know about the sides of a square? They're the same, which is why we can do S squared. So to solve for a length of that side, you would square root both sides, and the square root of 81 would give you 9. So each side of the square is 9 in units, centimeters. So my final answer, once again, would be 9. All right, so we just did an example, once again, of a cone, a cylinder, and a pyramid. 3 popular shapes that you'll probably see in your lessons and exams. The last review is going to focus on literal equations. What is a literal equation? It's an equation where your variables, aka your letters, they represent known values. Given an equation with many variables, To solve for a specific variable means to isolate, aka get that alone, that specific variable. So here's two examples that we'll take a look at. The first equation, area equals base times height, that works for any rectangle or the square. Length times width is what I chose to use instead. And we're going to take this literal equation consisting of all variables, and we're going to rearrange it so that we get b alone. So how do we do that? How do we get b? Well, you're going to use your inverse operations. So my focus is to get that base alone, and I notice that next to it is height. And what am I doing to the base and the height? I'm multiplying. So your inverse operation of multiplication, aka the opposite of multiplication, is division. So your next step is you're going to divide both sides by whatever's next to it to get it alone. So I am going to divide both sides by h in an attempt to get my b alone. Oops. So once again, divide both sides by h so that I can get that b alone. And then your final answer, rewriting your equation, that b is now alone. The h's have canceled on the right side. And you end up with b equals capital A over h. And we've now taken one equation and rearranged it in terms of another variable. Here's one more example on the right side of the screen. A equals pi r squared. This is the equation for area of a circle. We're going to now solve and rearrange it for r. So we're going to isolate some variables in order to do that. My focus is to get this r alone, but the first thing I notice is there's a pi right next to it. So how am I going to get that alone? I'm going to divide both sides by pi. Now the reason why I just divided both sides by pi is that the pi on the right side is going to disappear. Leaving me with A over pi equals r squared. But I'm not done yet. The question asked me to solve for r. I now have r squared. So what's the inverse operation of squaring something? It's going to be to square root. So I'm going to square root both sides. On the right side, the reason why I did that is the square root of r squared is going to leave you with r. And on the right side, you can't take the square root of that, so you'll just leave it alone. And your final answer is you get r equals the square root of a over pi. And we have now taken area of a circle and rewritten it in terms of the radius. So don't be afraid of literal equations. If you're able to solve an equation with letters and numbers, you should just be fine. Remember your inverse operations, and those will help you solve.